you get caught up to that step.
Okay.
So you can graph, and that's always going to work. What I would recommend is going to zoom and then either standard if you don't know what to graph, or this is kind of a shortcut, zoom fit, the one there. So I'm going to do a zoom fit, and I know to do that ahead of time, and that kind of helps me to frame the graph so that I kind of know what window it's it chooses the window for me to be able to fit that. Now, if you need to actually write down the window, you go back to the window button, and it gives you the X min, the X max, the Y min, and the Y max. So if we go back to the graph, maybe this isn't clear, but the X min is the leftmost X value, the X max is the rightmost X value, Y min, the smallest Y value, Y max. Now, if you're wondering why this looks like there's so much overlap, it's because the tick marks or the scaling is too big. So let me just adjust these numbers. So let me go like minus 50 to 150. And then I'm going to choose a scale of 10 this time. And what that does is it'll put a tick mark there. And this is just for making the graphs like prettier and easier to see. So I'm going to go back and graph that. And you can see the tick marks are a little bit more helpful there. So when your instructor says to, sometimes they actually want you to like tell them what window you used, and that helps because they're trying to see if you know how to do this. So the first thing it says to trace and find the value when x equals -7. You actually don't have to trace, like literally trace is like you're moving along here. Okay, left, and I'm clicking this right button, left and right. That's not really the right way to do it. The better way to do it is actually at second calc and then value. And then you can literally give it the x value. You can say, okay, what if x is -7? And see how it's perfectly -7, y equals -9. If you trace, you're not going to get it perfect.
Yeah.
And that's the problem. So I like second calc value, okay, to do that. So that's part A. Any questions on part A?
Yeah, just really quick. So you do second
Calc value. Yes.
And then it says x equals, so I just put in 7.
-7.
-7. Okay.
Yeah, because that's whatever it is,
Okay.
Okay. If it wanted it at 5, you would do the second calc, x equals 5. So for part B, and let me try to put some notes on this other page. It says, what is the y-intercept of the graph? The y-intercept is when x equals 0. So you can actually do the same thing. You can do a second calc value, x equals 0. Okay, and it's -16. Now you also could just read it off the graph or off the equation, because when x is 0, 0 squared is 0, 6 times 0 is 0. So it's just this last one, but it's the same thing there.
Okay.
So it's part C. Part C says to determine the x-intercepts. I'm going to go. So here, what we're going to do is we're going to do a second calc and then 0. Okay. And you see how it says the word left bound? Let me know when you get up to that point.
So it's second calc and then, sorry, what's next?
A second calc 0.
Oh, okay. So yeah, okay, I'm on the screen now.
Okay, so it says left bound. Okay, and when you're actually, I'm going to go back to the other screen for a moment, and I'll come back. So when you're finding a 0, this is your left bound. Your left bound is below. See, this is where it hits the x-axis, but your left bound is like just a little bit below it. Your right bound is going to be a little bit above it. And then it says to make a guess, you should always just choose the right bound. You don't have to like get any closer than that. So let me go back to the TIE 83 screen. So you have to choose something below. In this case, left bound is below there, and it doesn't matter how close you get. Like what some students do is they try to get right there. You don't actually need to get that close. You can actually be just in the neighborhood. So you hit enter when you feel like you've got it. Right bound, you want to get somewhere above it. So get far enough away that you actually are above it. Hit enter, and then like I said, it'll say guess, and just hit enter. You don't have to get near where it actually is. If you do that correctly, you get 2,0. Were you able to get that as well?
How did you find the 0?
Okay, so you go back to second calc 0, and it asks you to choose a left bound.
Okay.
So you choose something left of the 0. In this case, left of the 0 is below. So you just hit enter. You hit enter, you pick a point somewhere left of it, and then it asks for the right bound, and you go up somewhere there and hit enter again. And then it says guess, and you hit enter again. And you get that.
Okay.
Did you get that point?
Yes.
Okay. Now to find the other 0, okay, I'm going to go back to this other screen here because when it's going the other way, your left bound is now up here. This is your left. This is your right. And this is and then your guess ends up being there. But this is the one this is where we're trying to get. We're trying to get this point right here, but left is now above it, right is below it. So it could be, if you look in the previous example, left was below it, right was above it. It just depends on which way the graph is going. All right, so let me show that again here. Let me go to the TI-83. So again, you're going to go second calc 0. Okay, and again, like left bound here, I'm clicking. You'll be pressing the buttons there. You want to get left of it. So see, we think it's kind of right there, but we go left of it. We go somewhere far enough left. Now, sometimes the cursor goes off the screen. You just got to get back to where you can see it, and you hit enter. Now it asks for the right bound. Right bound is below it. So you go below it, hit enter, and then you guess. And hopefully if you've done it right, you get -8,0.
So for left bound, you go slightly above, and then
It's
right bound.
slightly below, but that's only when the curve is above and then below versus below and then above.
Okay.
Make sure you get -8,0. Like that's really important here, that you get that point.
Yes, that's what I got.
Okay, fantastic. So the rest of part C is saying like does this give you the same result when you factor? Yes, the answer is yes, of course it does. So part D is where the minimum occurs. So I've got to do a little bit of window changing here because we actually need to see a little bit more of this. We need more room below it. So I'm going to change the window. I'm going to change the Y min to be negative, I'll go 75. And yeah, that's good enough here. So to find the min or the max, you go second calc, and then you can see there's options there, min or max. You got to choose the right one depending on whether it opens up or down. So if it opens up, it's minimum. That's what we have. So you'll notice some of the same language. It says left bound. Okay. Now we think the minimum is kind of right in that area right there. So you want to go left of it. And the question is, well, how far left do you go? And it's like, well, far enough. You need to make sure it's truly left of it. Hit enter. right bound, you go right of it, enter, and then you guess always at the same spot. And there you go. You get -3, -25 as your minimum. So let me go back to this other screen. All of this is in that second calc. But like if you're finding a min, there's your left bound, there's your right, and there's your guess. When you're finding a max, you're going to go left, right, and then your guess is there as well. Is there anything you'd like me to clarify on that?
Yeah, so when you're setting up the window, how do you know like what's an appropriate amount so you can see the whole graph?
There's no like perfect answer to that. Let me go back to the graph calculator. So let me just do a zoom standard, which is a 6. If you were to just graph it, this is what it would give you. And what I was trying to emphasize is you can go right away to zoom fit, which is right after 9 at 0. You can go up to get that, but what zoom fit does is it tries to fit the graph in a window for you. And it's not perfect, but it does work pretty well a lot of the times. And so that gives you like kind of a good window, but I would argue it needs to go out further left. So like that, and that's where you make these like fine tune adjustments. Like I would say it needs to go a little bit more to the left. So maybe to minus, yeah, we'll go 20 maybe. And then there's, and then at some point you want to change your X scale. And then I don't like these numbers. That's why I went, okay, well, let's try minus, 50 and then 150. And then your Y scale is, I'm going to change that to 10. Those are the tick marks. And then you go back and you graph it to like, see if it works. Okay. You're like, yeah,
Okay.
it looks pretty good. It looks pretty good. You need enough, you need to be able to see the min. So you don't want the min to be so close to the bottom that you can't find it. If your intercepts are too close to the edge, you'll have issues with the left and the right and the guess and so on. Okay, can we move on to parts E and F, or do we need to do more from A, B, C, and D? A, B, C, and D are the kind of that pure calculator stuff.
Yeah, I think I'm good to move
You got
on.
it. Okay. So let me go back to the other screen here. Let me go new share. It's kind of one of the limitations of this. I got to go back and forth on it. All right, so here we go. So for part E, it wants to know where the graph is greater than or equal to 0. So we actually need to make kind of a rough sketch of the graph. We've already done it. So the rough sketch of the graph is that it hits at -8 and +2. So we want to know where the graph is greater than or equal to 0. That means it's above the x-axis. And you can see that occurs, here in this green part. Okay. But it wants the x value. So it's all the x values up to -8, but it includes -8 because of that greater than or equal to. And then it also includes 2 to infinity, 2 all the way up to infinity because it's always above. And then the next question says less than 0. That's below the x-axis. So that means it's got to be completely below. can't be touching. So it's all of this region, other region right in here.
Okay.
So in terms of like how you would answer that, it's all the numbers between -8 and 2, but it does not include the endpoints because it's a less than. If it's less than or equal to, then it would change to two brackets.
So for this one, it's just -8, 2.
For in terms of the question, so the first question, E is greater than or equal to. So the answer to E is this one. And then the letter answer to F is the one below it.
Okay.
And when you're answering these, I mean, if the graph opens down, there's some small shifts, but it's generally there's part that's always above and part that's always below, and that's what you're answering.
Okay.
So okay, so that takes care of question one. You can see how much effort went into that. Do you want us to do number 2, which is a calculator problem, or something else? Where should we go from here?
Um, Can we do number 2?
Of course, yeah. Just asking because it does take a bit of time here, but yeah. So we're gonna go. Let me just snip this one in, and we'll work it out on the calculator again. So your calculator is actually very useful. It's a very powerful tool. It's just it's generally underutilized in the classroom, and there's a lot of really cool technology available. Okay, so it says to solve all real solutions of this thing, and it says to do this by actually graphing this thing over here on the right. The reason that works is because they're subtracting 15 to the other side of the equation. So we're going to do that. We're going to go ahead and graph this. Okay, so we're going to go back to your y equals. So I'm going to share that calculator here.
Okay.
And go back to your y equals, clear it out. I wouldn't start overwriting. I would just clear it out. And this time you do have to use the caret button. X caret, where's the caret? Cubed plus 3x, and I'll use the caret this time, 2 minus 7x. Make sure you use the minus and not the subtraction. It will throw an error, minus 15. Okay, so now if you graphed this, if you go hit the graph button, which you do not want to do because when you graph it, it's going to have the same window that you had in the previous problem. And depending on your calculator, it can actually take a lot of time to load. I would recommend going back to Zoom and either doing a Zoom fit, okay, which is this one right here, or just a Zoom standard. But I'm going to recommend we do a Zoom fit because what it does is it tries to fit the graph as best possible. Okay.
Okay.
So if you get something like this, we do have this is kind of problematic because it's missing some stuff here. There's definitely some issues. So what I'm noticing is that there's a lot going on right in here, and we're not seeing it. Okay. So we need to kind of tighten up the window horizontally, but probably more importantly, vertically. So we're going to go to the window here, and I'm going to change this to -10 and scale to 1. Now that Y min, wow, so that's really far down. I'm just going to make a guess. I'm going to go -1000. And then I'm going to change this to 1000. I'm just guessing. I really actually don't have a good feel for this. And I'm going to change the scale to 100. The reason 100 makes sense is because it's a big increment here. And then I'm going to graph. But this is very much like a try it and see if anything good happens. So a little better, but you can see we really need to narrow in on the y. The y's are way too far up and down. So I'm going to go back to my window and I'm going to change the y. I'm going to go down an order of magnitude. So minus 100. Make sure you use the minus this time, not the subtraction. And then 100 here. And we're going to see. And then we change, actually, we change this to 10. And we'll just graph here. So hopefully, okay. So a little better. So see how you kind of get it goes up and down, but we still need to kind of tighten in on this. Now there's some other things you can use. You can do this like zoom box, which I think students do. Like I like to just mess around with the window, but it's totally your preference. So I'm gonna go minus 30 to 30 and change this to like 5. I still don't have a good feel if this is going to do enough, but yeah, it kind of did. Yeah, that kind of did. So that's pretty good. So there's my window if you need to get caught up to that. It can take a little bit to kind of get it perfect the way you want.
Okay.
Okay, now the first thing it asks you to do, it says to determine the real solutions. So it wants where it crosses the x-axis. So there's 1, 2, and 3 crossings. So to find that, you're going to go second calc 0, and it's going to ask for the left bound and the right bound. So I'm gonna just go left to right here, meaning I'm going to find this one first, and then the second one, and then the third. The left bound needs to be somewhere left of it. So that's pretty close. So I'm gonna hit enter, and then right bound somewhere above it. That looks good enough to me. And you always guess the same place. So please confirm that you know, hopefully you've got the same thing if you're doing it. It's really important that you cannot trace it. If you try tracing it, you will not get the right answer.
Yeah.
Right answer. So, you know, keep that in mind. So that's the first one, minus 3.81.
Okay.
So to find the next one, you're going to do the same thing. You do a second calc 0. Okay, and this time the left bound is above. It's left. It's like, where's left of this point? Well, left happens to be above. Right bound is below. And then you guess right there. So minus 1.62. Okay, and then to find the third one, same thing, second calc value. Sorry, 0, not value. And left bound. So sometimes students like you need to get reasonably close. Like if you try it over here, it might work. You really do want to get kind of closer, and that's why the window is so important. Right bound, just a little bit right of it, and then guess, and you should get this point there. So hopefully you got those same 3 values. Okay, so if I go back to the other window, what we did is we went into y1 and we solved, we graphed this 3x squared minus 7x minus 15. But what they're saying in part kind of A/B is that there's another way to do it. And the other way to do it is the thing on the left side of the equation. Actually, let me rewrite it here. On this thing on the left side of the equation, this is going to go into y1, and the thing on the right side of the equation, y2. Okay, and this time we're going to find the intersection of them. Okay, so I'm gonna go back to the calculator. I'm gonna go back to the y equals. I'm gonna clear this out. Actually, I should not clear it out because you can just edit it. So I'm gonna, it's, the calculator was designed before iPhone. So if yours, if it doesn't feel intuitive or you get upset, like just, it's not, it doesn't work great. But this is the Y1, and then in Y2, you've got a 15. Y1 and Y2. Okay. So let me know when you've got this plugged in, because we do want to graph it.
Okay.
All right, so I'm going to graph, and we've got, that's the cubic, and then there's the 15. Okay.
Mhm.
Now what I'm going to do, I guess I'm going to do the zoom box, I guess. Have you been using that in class
The
at
Zoom
all?
box.
Yeah, have you been using that at all?
Um, a little bit, not much.
Okay, so I believe you grab like the top coordinate. So I'm going to hit enter, and then you go and you go top left to bottom right. So I'm just dragging this thing out to the right. I mean, we're so used to just dragging, with a phone, but what you do here is you kind of box in just the area that you want it to zoom in on. Okay, and then you hit enter. And what it does, it just makes it a little bit easier to kind of zoom in and see what you want. So this time we're going to do a second calc intersect. Now you do not have to do the zoom box. The way the second calc intersect works is it wants the first curve. Okay, so first curve means like your cubic. So you hit enter. Your second curve is the other line, and you got to be on you. It's got to be one and then the other. You hit enter, and then you always guess where you just were, and that 3 minus 3.81 or 80 is the same. It's the same as the last one.
I got negative 3.7.
Well, maybe there's maybe there's something on yours. X cubed plus 3x squared minus 7x. Yeah, I mean, check that these are the same. If there's anything off with these.
Yeah, it's the same.
Okay, maybe just try it again. So you can always go back and do a second calc, intersect again. And like the thing that's interesting is it actually doesn't matter which curve you choose first. Like I can choose the line first, enter, and then I'm going to grab this other curve, hit enter, and then you always guess at the same point. And I get that minus 3.80 again.
Okay, I got it.
Okay. And so you have to repeat this process, but what the instructor is trying to show you, and this is actually a really good exercise, is that you can see that you're going to get the same answer. So you get to choose which one, which way you want to go. So I'm first curve. It doesn't matter which one's your first curve. It should jump you to the other curve once you choose the first curve, and then you always guess at the same place. But you got to get nearby. Like you can't use the points over here. You got to get kind of close.
No.
It's like if your friend says, hey, I can't find your house. It's like first thing you ask them, like, why are you in my neighborhood? And that's what we're doing here. You got to be close enough that we can help you.
Mhm.
Okay, and then last one, so second calc intersect, and you're noticing, hopefully you're seeing that they're the exact same points. So you just move along the curve. There are other ways to do this faster, but this is what most students do. First curve, enter, second. So if you get close enough, it jumps you close enough to that second curve where you don't have to do much. Hit enter, enter, and then you got it. So any questions about that?
No.
Okay, so then the next one, it says give the coordinates to the two decimal places where the minimum value of this graph occurs. It's not specifying whether they're referring to the original or like which one it is. So let's go back to putting minus 15 in that first one. I think that's what's referring to. Instructor didn't specify, but I'm going to go back and graph that one. And I'm removing the other one. So now notice it doesn't really fit. So I've got to change the window. So I'm gonna go, and you can see it's all kind of messed up here. It's not clean. You don't have to change all the values. You can just change the one that you need to. So like for me, this y min, I'm going to change to minus 30, and hopefully that's enough. What we're looking for is the min right there.
Okay.
So to find the min, you do the same thing we did for the parabola. You do a second calc, and you got to decide whether it's a min or a max. In this case, it's a min. And now it's saying left bound. So your left bound better be left of it. Like if you go right of it, it will not work. So you have to literally go left of where you think it is, and just be in the vicinity. There you go. And then you trace to the right bound, go right of it, see where it is, hit enter, and then guess there as well.
Okay.
Okay, so then the next, and I'm going to go back to the other screen here. The next question, or part of the question, it says to part D, it says to solve x cubed plus 3x squared minus 7x minus 15 less than 0. And we know that roughly the graph looks like this.
Mhm.
And I mean, full disclosure, I didn't actually get the points, but I think this was like minus 3.80. This one was like minus, feel free to help me out here. Do you have these numbers?
For which one?
Where it hit the axis? I'll go get, yeah, sorry, I didn't write them down because it's like, all right, let me calc 0. Won't take that long to get these. All right, so enter. So this one over here is at 2.43. And then the one in the middle there, 0. So we'll go. This one is at minus 1.64. So when it asks where it's less than 0, it's asking for wherever the graph is below the x-axis. So we did this in the last problem. So it's all of this part here, and then it's this part here. So where is it less than 0? Well, it's less than 0 from minus infinity to minus 3.80. So we're looking at the x values. And then from minus 1.64 to 2.43. That's where it's less than 0. It could also ask you where it's greater than 0. So it's greater than 0 in these other regions.
Okay.
All right, so that takes care of that question. You sent over some like trig review things.
Yeah.
Should we, I mean, we can do like, there's some stuff on sine, cosine, there's, I don't know, what else can we do? We got, 10, 11, 12 minutes. There's also some graphing, 3 to the x minus 1. Where should we go next?
Could we do the backside of the diagnostic? It's graph h of x
Yeah,
equals
yeah,
x.
yes, yes. Let me grab that here. All right, so the next question here is, there's a lot that goes into being able to do this. The first thing is to know the parent function. They sometimes emphasize this at your school a lot. The parent function is 3 to the x, and it's exponential growth. So it looks something like that. Okay. Why? The reason you need to know that is it helps with the transformation. This x minus 1 is a transformation. This minus 9 is a transformation, and that x minus 1, it's very similar to like the quadratic stuff and the absolute value stuff. This tells you that it goes right 1 because it's kind of opposite what you'd think it would be. So the transformations are right 1 and then down 9.
Okay.
And now in terms of graphing this, you would normally, if you're doing the parent function, you would normally do like, sometimes you can get away with only doing 3 points, like minus 1, 0, and 1. Yeah, that's 3 to the minus 1, 3 to the 0, and 3 to the 1. So it's 3, 1, and 1/3. Sometimes you can get away with just doing that. But for the new one, for the one that they're giving you, it's a bit more complicated. So it's x and then y equals 3 to the x minus 1 minus 9. This is where there's a lot that goes in this, but you choose the number that makes this 0, this x minus 1 0. So that kind of centers you. And then at a minimum, you want to go one larger and one smaller. And maybe we'll do more than that, but we'll start with this. So we put this value into the equation. So it's 3 to the 1 minus 1 minus 9. 1 minus 1 is 0. 3 to the 0 is 1. 1 minus 9 is minus 8. Then it's 2 minus 1 minus 9. So 2 minus 1 is 1. 3 to the 1 is 3. 3 minus 9 is minus 6. Now you might think the thing is always negative. And that's why I said, well, maybe you need to do a few more points. So if you put a 3 in, you get y equals 3 to the 3 minus 1 minus 9. There's your 3 squared 0. And you may even want to do one more. So you finally get something that's positive. 3 cubed is 27. 27 minus 9 is 18. Okay, and this is probably truly enough to graph it. You could, like, it depends. Sometimes your instructor will say 5 points or 4 points or whatever.
Mhm.
But that's sometimes enough. Now, the other thing that goes into this that they really emphasize a lot when you're taking the previous class, they say this number right here, this minus 9 here, it is the horizontal asymptote. Now I haven't really done a good job of drawing this, but 1, 2, 3, 4, 5, 6, 7, 8, 9. So they say that's your horizontal asymptote right there. And then you just graph these other points. So 1 minus 8, 2 minus 6, 3, 0, 4, 18. So it's really hard to get it in there, but the graph looks something like this. I mean, you've got it on yours.
Mhm.
They're looking for the table work and the points. And if you didn't kind of follow all this, the other way to look at it is like, choose points that you can actually do. Like if you put 0 in, it's 3 to the 0 minus 1. That's a third. The third minus 9. That's hard. Like try to get back to points that are, more straightforward for you to do.
Okay.
That's reasonable. Okay, now x-intercept work. X-intercept work. So the instructor is basically saying, like, show me your work to find the x-intercept here. The x-intercept is when y equals 0. That's the x-intercept. Or if they don't give you y, that really means h of x or f of x or g of x or whatever your function is. You set that equal to 0. So in your case, you're setting h of x equal to 0.
Okay.
Sorry, -9. I don't get this. Correct. Sorry, it's -9. So now you're solve for x. So to solve for x, you're going to add 9 to both sides. 9 equals 3 to the x minus 1. Since you don't know logarithms, you have to make this 9 into a 3. And you do that by using a base to a power. 3 squared is really 9. Okay, and so when the bases are the same, you can set the exponents equal. Okay, so that's 2 equals x minus 1. You add 1 to both sides and x equals 3. Now we happen to already see that in the graph, like your graph on your page shows that right here, 3, 0. You also have it from the table right here. This is your x-intercept.
Mhm.
Okay, so that like you can do all this, but you also kind of have it. So I'm not sure if you need to show the work formally or if you can just say, look, I mean, you did in your worksheet, you showed the work, but it kind of is already there in the table. Okay, y-intercept work. So the y-intercept is when x equals 0. And we avoided doing that in the table because it doesn't work out nicely, unfortunately, but it's literally setting x equal to 0. So you're putting 0 in for x, 0 minus 1 minus 9. 0 minus 1 is -1. 3 to the minus 1 is 1/3. And because we've been doing a lot of fraction practice in our standardized prep stuff, you probably are going to say, oh yeah, I could just convert that to a common denominator. So this becomes -26 over 3. And that's your y-intercept.
Okay.
So I am looking at your sine, cosine, tangent graphs. They're not quite correct. This is something you will see in pre-calculus again, the trig part. You probably saw it a little bit in geometry, but so the graph of sine x, okay, so the graph of sine x, it extends forever in both directions, but it starts at the origin. It goes up, down, down, and up. And so you have to somehow like visualize this. And teachers like to say know it cold. I prefer to say, like, when you wake up in the morning, you know what it looks like because it's so familiar to you. This is what sine looks like. Cosine looks like this. It's very similar, but there's important differences. It starts high rather than starting at the origin, and it immediately goes down, down, comes up like this. So it comes down, up looks like that. So you definitely need to know that for this. And then tangent's kind of less important. It's got some other things going on. I mean, you can spend an entire unit on graphing these things, but tangent actually has some asymptotes. It starts down here and goes up like this. So I'm not sure where they're going with this, but looks like you did it today in class. Yeah. All right, so please try the calculator stuff again before your diagnostic. It's the kind of thing that there's a few like little steps. So if you don't remember them, definitely look back at your notes.
Okay.
It really, if you do it once or twice, once in the morning or once before your test, you should be able to get it pretty quickly.
Okay.
All right, well, I think that takes us to the end of our lesson for today, Julia. Thank you so much for scheduling. I'll send you the notes here shortly, and I'll see you next time.
Okay. Thank you so much.
You're welcome. Bye now.